Could a spoonful of neutron star destroy Earth? It was the kind of question only a very bored physicist or a very curious child might ask. What would happen if you brought a spoonful of a neutron star to Earth? Let's say, just for fun, just for science, that a perfectly spherical lump, about the size of a teaspoon, was somehow teleported from the core of a neutron star and now hovered a few meters above the Pacific Ocean. No spacecraft, no containment, just floating there. It would look unimpressive, tiny, maybe heavy-looking, but still just sitting there, seemingly harmless. People would gather, cameras would roll, scientists would argue in loud, anxious whispers. No one would know what to do, because no one had ever seen a teaspoon of pure neutronium just hanging in Earth's atmosphere, and no one would live long enough to write the report. Neutron stars are born in violence. After a massive star explodes in a supernova, what's left behind is an object of immense density. The core collapses in on itself. Electrons and protons melt into neutrons. Gravity compacts everything until the atoms themselves cannot hold form. There are no spaces between particles anymore. There are no atoms. Only a vast nuclear soup, packed tighter than anything nature normally allows. 1 cubic centimeter of this material, just a sugar cube's worth, weighs hundreds of millions of tons. A teaspoon, roughly 6 billion tons. That's the mass of a large mountain range, compressed into something you could theoretically stir your coffee with, if you were suicidal, or a black hole. Now, back to Earth. This spoonful of neutron star matter cannot simply sit here. It's not just heavy, it distorts space itself. Gravity does not scale politely, it spikes violently around such densities. The moment the neutronium appeared, Earth would notice, not intellectually, but physically. The air would rush inward, the ground would tremble. Water from the ocean below would leap upward in vast sheets, drawn by the newborn gravity well. The rock beneath it would fracture, pulled toward the object as if magnetized by madness. Entire tectonic plates might creak and shift. Within seconds, this single point would begin collapsing downward, burrowing through Earth's crust as though everything around it were made of soft butter. Except it wouldn't stop. Earth's surface would not be able to support it, not the mantle, not even the core. The neutronium would punch through every layer, accelerating as it pulled surrounding matter with it, crushing rock, boiling metals, dragging a growing shell of superheated debris in a downward spiral. And then comes the real problem. Neutronium can't survive on Earth, not in our pressure, not in our gravity. The only reason it holds together inside a neutron star is because the pressure from the star's own mass holds it in place. Remove that pressure, and the structure unravels. So, the teaspoon of neutronium would destabilize. It would decay rapidly, maybe explosively. Neutrons aren't supposed to exist by themselves. They decay into protons, electrons, and neutrinos. But this wouldn't be a peaceful process. It would be catastrophic. Because in neutron star conditions, neutrons are packed so tightly that when they decay outside that pressure, they do so with violence. Like a chain reaction, a decay wave of nuclear fury. That decay would release energy, not in the form of fire or a nice glowing light, but as a chaotic burst of ionizing radiation and kinetic force, like all the energy of a dying star compressed into a flash no longer than a blink. Everything nearby would be vaporized, rocks, ocean, air, everything. It would make Hiroshima look like a sparkler. It would make Tunguska seem like someone dropped a match. This would be something new, something final. And worse, this decay wouldn't happen quietly in one spot. The neutronium, as it destabilized, would spray particles, trigger reactions in the surrounding matter, and possibly seed microfusion bursts. We wouldn't get a crater, we would get a hole through the planet, a rapidly widening wound in the crust and upper mantle. The surface temperature would spike, the magnetic field might shift or collapse, and the global ecosystem, done. The atmosphere, ripped, ionized, gone in places. It would be like someone had dropped a pin of pure collapse into the center of our delicate blue marble, and Earth would bleed energy until it broke apart. It wouldn't be a cinematic explosion, no mushroom cloud, no dramatic shockwave sweeping over city skylines, just pressure, radiation, silence, and then collapse. Over hours, the planet might hold together. Over days, it might split, a tear growing outward from the original point. swallowing land and sea alike. Earthquakes wouldn't roll, they'd radiate. Waves wouldn't crash, they'd simply stop, caught in frozen arcs as tectonic violence outpaced water's ability to react. And the spoonful? It would be gone, either decayed into normal matter, dispersed through the molten wreckage of what once was a planet, or fallen inward toward the shattered core, pulling Earth behind it in a suicidal embrace. So, could a spoonful of neutron star destroy the Earth? Number. It wouldn't just destroy it, it would rewrite the very idea of destruction. Not a bang, not a blast, but a slow, absolute, merciless unmaking. 1 teaspoon, one impossible mass. And then, nothing.